Good morning. This is Anthony Ambrose from Data IO Corporation, and I'm here to talk to you today about the new programming challenges in automotive electronics. As many of you have heard, automotive electronics are undergoing a boom in the industry right now. Many new exciting platforms have been developed and introduced, and these products are fantastic because they create demand for consumers. But for the manufacturers, they create some very interesting challenges in terms of how to program these technologies, how to deliver them at low total cost of programming. And what you'll hear today from us is a little survey of the overall market, as well as an understanding of the architectures and technologies, and then some ideas from Data IO on how best to move forward and program these systems. First, a little bit about Data IO. Many of you know us as the leader in device programming. We've been in the industry for over 40 years, and we service the industry's leading manufacturers, programming centers, and contract manufacturers to do their device programming in manufacturing. We support tens of thousands of devices with a full range of manual and automated systems with 24/7 support globally. Many of you have heard about the fully autonomous vehicle, and this is an exciting long-term roadmap for the automotive industry that over the next 10 to 20 years will allow us to transition from today's technologies to technologies that will allow us to drive, essentially have the car drive itself. What this means for the automotive electronics industry is there is a huge secular boom in the content of automotive electronic systems necessary to support today's demands, but also to be preparing the eventual transition to a fully automated car over the next decade or two. What we have is an industry set of descriptions talking about the pathway to self-driving cars. Today, as you can see, we're generally in the automotive driving level 2 of autonomous driving. This includes parking assist, programs for lane control and braking systems, autopilots for traffic jams, and we'll see these move forward to autopilots for parking, highway driving, etc., as we move towards the self-driving car in the next 10 or 20 years. As a practical matter, these subsystems are all very exciting, but they require much more computing, memory, and I/O capacity in an automobile than we've ever seen before. And as many of you know, computing and memory and I/O mean a bigger demand for programming as well. If we look at the Clemson University Vehicular Electronics Laboratory, they put out a very interesting tutorial on the types of systems that are in automobiles today that require electronics and programming content. As you can see here, from the front of the car to the back of the car and everything in between has seen growth in automotive electronics content. Whether it's infotainment systems, tire pressure recorders, lane control, anti-lock brake systems, security systems, there's a substantial growth in the content in electronics in cars, and it's all happening right now. What does this look like specifically? Well, if you're behind the wheel of a car, the first thing you see is the dashboard. And if you look at the diagram on the left, it's a very sophisticated dashboard complex from an Audi TT. Very traditional in its design. You have moving needles for the tachometer, for the speedometer, and gauges for oil and gas. You also have an indicator warning panel if the trunk is open or the door is open. Very easy to see, very easy to read, but it represents where technology has been. Now if you look at where the Audi TT is today with the virtual cockpit, you can see that the fundamental architecture and system and driving experience has been fundamentally changed. What you see now is essentially a graphics computer that's painting images of a tachometer and a speedometer onto an image of a map or representation of the driving road ahead of the driver. This is a very big change in terms of not only functionality for the customer, but a very significant change in the architecture of the systems underlying the infotainment complex. What you see here is, in practical terms, a system on the right requiring tens of gigabytes of memory to be programmed. All of the maps, different languages, all the different features that go into a system consume more memory than even a tablet computer. On the left, although a very sophisticated system, because the technology is fundamentally analog, the capacity of programming was actually very, very low. So you've gone from a situation with a few megabytes of code now to tens of gigabytes. And this represents a fundamental disruption in the memory size required to program dashboard computers. The methods that have been used to program when you only need megabytes, frankly, choke. They cannot keep up when you go from megabytes to tens of gigabytes of programming. And these infotainment systems are forecast to grow substantially in the next 10 years. What you're seeing now is about 50 million units a year of demand, easily surpassing 125 million units of demand by 2020. So more than doubling the growth in the next 4 years. So the problem we're seeing today is real, and it's going to get even more substantial as more and more of the systems convert to infotainment systems. So what does this mean for manufacturing technologies? Well, very simply, the new designs feature central processing units, graphical processing units, and large flash memory arrays, again with about 20 to 60 gigabytes of content. And as I mentioned earlier, this is a fundamental shift in architecture from previous generation of products, and it causes a 10,000 times increase in programming demand. Now, this 10,000x increase is very disruptive to existing factories that are used to 10, 20, 30% increases in demand in any given model year. And a 10,000x increase simply means that whatever you did before won't work. You have to change your manufacturing methods to keep pace. What we're seeing also is the large flash arrays as part of these new infotainment systems will not be programmed using the same post-placement equipment as small microcontrollers. We've talked about the fact that small microcontrollers have been programmed to test or programmed within system programming applications. And those are great when you have a couple of megabytes of code, but they simply will not work when you have a multi-gigabyte image. And manufacturing engineers, plant managers in the automotive industry are faced with this highly disruptive change of content, and they're figuring out, how do I keep up, how do I program all of these different systems when what I've been doing in the past simply won't work. What they need to think about in these new programming systems is, how do you get high-speed programming engines capable of handling 40, 50, 60 gigabytes of information, both reading and writing at the device specifications for high performance. These engines have to be of the highest quality, they have to have very high yield, outstanding data retention, and very high reliability programming. As a practical matter, you're going to be looking at a highly parallel large capacity system for maximum throughput and low operating cost. The problem of programming a large flash array lends itself to these parallel systems. Customers also will demand everything works with their automotive factory, and this includes laser marking, 3D coplanarity for inspection of leads. It also means that all of the interactions with their manufacturing computing systems, including traceability, job statistics, are in place. They also have to have the ability that they have today to roll back revisions and control any changes, and be prepared to have a failure analysis capability should anything be determined to be wrong many years down the road. Of course, they want their suppliers to have strong industry relationships and proven global deployments. When we look at these requirements and we look at the challenges of the architectures of new infotainment systems, one system in the industry stands above all the others. This is the PSV7000 programming system from Data IO. When combined with the Luminex programming engine, it simply surpasses all other systems by a factor of 2 or 3 in its ability to program large flash arrays for automotive infotainment applications. As you can see here, some quotes from current Data IO customers. One customer told us they were able to do the work of 2 to 3 competing systems with one PSV7000. Another customer swapped out an ISP system and standardized across their company on PSV7000 because it offered the capacity they needed at the lowest total cost of programming. And let's drill down a little bit more and understand the architecture behind this system. As Data IO announced earlier this year, the Luminex programming platform. We're very pleased to announce that we won the Global Technology Award at Productronica, the industry-leading trade show in Munich, Germany, earlier this year. Luminex brings unparalleled performance, scalability, and security to programming automotive electronics applications. What Luminex does very specifically is program the parts at wire speed, which lowers the total cost of programming up to 73%. We do this by bringing in the latest technology in a way that's highly parallel and can be scaled out across the entire PSV7000 platform. This makes programming with Luminex faster, more secure, and lower cost than other forms of programming and duplicating technology commonly used in automotive applications. And because the Luminex platform has been integrated into the PSV7000 handler, you get all the benefits of the proven PSV7000 integrated software and ability to integrate back into customers' computing environments in their factory. But Data I/O has a long history in flash memory, not just in the automotive electronics market, but in the mobile market. Data I/O pioneered NAND programming with our bad block management and high performance programming over 15 years ago, and is the leader today in eMMC programming globally. And wire speed programming of eMMC devices, along with automation, gives customers the lowest cost and highest quality. And we've been able to prove this with over 1 billion parts successfully programmed. So if you look at today who's using the PSV7000 and who's using our programming technology, well, we're very pleased to report that 8 of the top 9 automotive electronics OEMs and 5 of the top 5 automotive programming centers are Data I/O customers. These companies have the PSV7000, they have Luminex, and they have some of our legacy platforms as well, supporting global customers in the automotive electronics industry. So I'd like to summarize by just reminding everyone that automotive electronics content's a real growing market. We have a tremendous explosion of content occurring across the industry. But these new systems and applications bring challenges in manufacturing. And these manufacturing challenges require new programming methods and new systems. Fortunately, Data I/O has proven with our PSV7000 technology and Luminex programming platform that we can support all of the needs of the automotive electronics industry, including these new high-demand infotainment, dashboard computing, and navigation systems. And we're very pleased to report that automotive leaders globally have selected Data I/O and our PSV7000 platform for their programming needs. Thank you very much.